Hi, everyone, and thanks for joining the session. And thanks to Solution Monday and Pepper Data for sponsoring the session at the DataStack Summit. I'm Mark Kidwell. I'm the Chief Data Architect, the Data Platform and Services team at Autodesk. I'm here to talk about optimizing the modern data stack for price and performance. For folks who haven't used Autodesk products or aren't familiar with us, Autodesk is a global leader in design and make software. Our software is used by industries, including media and entertainment, architecture, engineering and construction, product design and manufacturing, and it helps engineers and creators to bring their ideas to life. Inside Autodesk, we use data extensively for insights into our products and to measure business performance. The amount of product data that we generate is in the terabytes per day. The amount of insights and people using our data are very large. So we have a dedicated data platform group and data platform called the Analytics Data Platform that brings in over 100 data sources from all of our products and internal services and back office systems. Our data platform is built on the AWS and Snowflake data ecosystems. And it's not just the technology, it's a number of platform teams and data teams collaborating while using the platform. And the question is, why do we need a platform? At our scale, we have far more data than any single team can manage. We've adopted a multi-tenant data platform model with a data mesh architecture where we have data brought in by data publishers or producers, published to their consumers on our platform. Those data publishers and producers span our data warehouse and data lake. They're considered tenants of our platform. And as such, they have the ability to see their usage, connect directly to their consumers, and understand how to use our platform through a self-service model. One of the challenges, though, with a large-scale platform is the sheer scale of the operations and the number of teams that have to work together for the platform to be successful. This is just a high-level view of our big data platform, our data lake, built on Amazon Web Services using EMR and Spark. The platform is actually served by a platform team composed of infrastructure teams, teams developing tools, and teams operating the platform. And it's used by data teams who are responsible for their data ingestion or data products that they're building for their consumers. Those data teams could be bringing in enterprise data, like CRM data. They could be bringing in product data, usage data, or any number of data sets brought in by the teams here. There's at least 40 teams in total working across the platform. Although we have all these tools in the platform and we have people supporting it and using it, we always have a challenge figuring out, are they using it the most efficiently and what's the cost of their usage? Just to give an idea of some of the problems we have running a platform, especially with Spark. A team might optimize their Spark jobs or their workload manually, and it works fine for them. Sometimes their data set volume or number of users change, or the team would go and manually change other application settings or cluster settings to optimize for that. Other teams might be aware that they had made those changes and make their own changes. When all these teams are unaware of the changes going on and how they impact the overall platform and the others, the result is runaway costs. So every time somebody makes a change that uses a larger cluster or uses more data, the platform incurs the cost. Spark in itself presents a unique set of challenges. For folks who have used Spark for a long time, they may be familiar with the challenges of running it at scale. It's very difficult in general to tune Spark for optimal usage of memory or compute for every kind of workload. It requires a very deep understanding of Spark to do that successfully, and great tools to observe what's happening at the result of each change. Other kinds of challenges with Spark, it may only be possible to see the cost and expense of using Spark compute at a cluster level. In other words, not being able to see it down to individual jobs. And Spark itself is a challenge because it's, while widely adopted, not necessarily the best platform for every use case. It is kind of a one-size-fits-all solution. And especially when a team wants to use Spark and chooses to use something that worked for another team, it may not work well for them. Each of these problems does have solutions. For tuning, the ideal way to do it is to automate ways to identify these problems and optimize Spark. For getting better insights into Spark performance, instead of doing that at a cluster level, it's really important to understand it at the job level or application level, but still be able to attribute it to a particular cluster, team, or workload. And as far as figuring out what the right size or type of Spark cluster is used for a different team, it requires understanding their use cases and giving them the appropriate compute capacity. Just backing out a little bit though, these challenges aren't just for Spark. These are for any data platform team. And overall, our data platform team needs solutions around these areas: monitoring and optimization solutions for working with cloud platforms as well as big data platforms. We need a better way to measure usage and quantify waste. It's very difficult to understand usage in a cloud platform by particular tenants. It's even more difficult to understand if that usage was efficient, if it was solving an important or worthwhile problem, or if it was just wasted on compute unnecessarily. The other thing we need out of any kind of solution for monitoring is the ability to automatically and autonomously tune for cost savings. In the ideal state, we're not just getting insights or recommendations from a cost management system. The system is actually applying these changes to our products, to our clusters, to our compute, and saving us money. And finally, part of the problem is not technical or technology at all. It's people and process. Continuing to educate people on the right way to use the platform, ensuring they're aware of the processes in place for automatically tuning it, and just general best practice around the types of technology they're using are all important to successfully managing costs on this platform. I'd like to talk a little about how we approach some of the technical aspects of this using Pepper data, and at least solving the challenge around a big data platform using Spark. When we started with Pepper data, we were attracted mostly to the ability to observe our workloads, but also to automatically optimize them. The capacity optimizer and managed autoscaler features allow us to autonomously tune our clusters for the Spark workload that's running on them at that time, without us having to continuously or manually make changes that might be lost as a workload changes, teams change, or any other changes occur to the system. What we also got out of adding the Pepper data solution to our stack is a good ability to monitor our big data jobs and processes running on Spark. Something that we could only do at a high level before, using standard or out-of-the-box tools for Spark, like the Spark History Server. We now get a lot richer or deeper insights into what jobs are actually doing, something that we, like most companies using Spark, might struggle with. When we migrated from an existing cloud provider for Spark to Amazon EMR, we wanted to ensure that we could continue to monitor and optimize our Spark workloads. Luckily, we had that built in and out of the box with Pepperdata. We didn't have to do any additional work during the migration. And in fact, after the migration, we used Pepperdata to help optimize workloads even further. Another key benefit that we have using Pepperdata is the automation of the rollout of Pepperdata with our stack. Prior to our migration, we manually configured things, or it wasn't consistent across Spark clusters or other workloads. As we've added additional automation, we built Pepperdata into that automation. So every single Spark cluster we spin up automatically gets instrumentation and monitoring through Pepperdata. Just a little more information around how we use Pepperdata. We use it to both run and optimize our Spark workloads. On the left, the screenshots are both high-level and detailed views of our Spark clusters, the amount of waste that might have occurred across them, and details for a particular application on how it's performing, what needs to be changed to improve performance or to troubleshoot it. On the right side, this screenshot shows how we've optimized our clusters automatically with Pepperdata. We didn't do anything special to enable these savings other than enable it through Pepperdata configuration. But Pepperdata shows us exactly how much it's changing the performance or capacity of the cluster and how much money it's saving us while it's doing that. A few of the benefits we've realized since adopting Pepperdata, but also adopting more of a cloud cost conscious strategy. We've seen a lot more efficient resource utilization. Where we used to have resource utilization on our Spark clusters in the range of, say, 30%, we now see those clusters running at about 70% utilization. This directly impacts our compute expenses. If we're using 70% versus 30, we've doubled the efficiency and halved our costs of compute to run the same workload. Internally, we've also established better management processes for making changes, automating the rollout of clusters, and how to make changes to applications to tune them better to run more efficiently on Spark. And really, all of these things have allowed us to scale. As a platform team, we expect nothing to be lower than the day it was before. We are always growing. We're always adding more teams, clusters, and applications, and more importantly, more data. Without this kind of cost management in place, our costs would continue to scale proportional to that. Luckily, they've been held in check, and we have more insight into where we're spending money. This hasn't been a quick journey, and where we are now and where do we go next is driven by where we've been. This model here comes from the FinOps framework, showing the inform, optimize, and operate virtuous cycle. We've probably been around this cycle twice now. The first time we did it adopting basic tooling, a basic optimization based on recommendations from the tooling, or automated optimization based on Pepperdata, and continuous improvement in how we operate. Recently, in the second cycle around this, we added proactive cost management to our stack via a homegrown solution, and have much more insight into all phases of our data platform, all workloads across different types of technology, not just Spark. So this includes other AWS services as well as Snowflake. And we've begun sending out and notifying users of recommendations they can make to optimize their platform. This year and beyond, we're continuing to fine-tune that process, adding additional data sets into our internal cost management reporting portal, adding additional use cases, users, and better recommendations, and also collecting feedback from our users on whether the recommendations were useful or not. The FinOps journey, while it looks like a straight line, definitely has not been a straight line. When we started, we didn't know the right way to even approach the problem, and lacked observability. As the crawl phase shows, we didn't know what we didn't know. It was a huge step just to monitor what was happening on our data platform, especially on our Spark clusters. Getting the basic monitoring and optimization in place set us up to move to the walk phase. We started moving more of the responsibility for managing costs back to the data teams themselves. We could only do that by having the data itself to show them about how they were using the platform and how optimally or efficiently they were using the platform, including Spark. It did allow us to do things like set budgets or other limits on spend and show users when they were exceeding those. In the last or final phase of our journey run, we ideally will hold teams more accountable or enable chargebacks. We don't do that today. We simply show the cost incurred. And we may not actually do a formal chargeback, but to be able to show exactly what teams have used, what resources in the most level of granularity, and make recommendations for it, really helps the platform team to justify the costs that we incur, as well as help users improve how they use the platform. And finally, we learned a lot from doing cost optimization and cost management through the FinOps journey, including adoption of Pepper data and other technologies. One of the things that probably stood out most of all is the need for continuous evangelism with our stakeholders. This includes executives or sponsors, the engineers working on the platform side or working on the data team side with the platform, and product managers to support the rollout of tools like this. Probably the most important thing around the tools like Pepper data and other cost management or cost monitoring and optimization systems is just the understanding the need for the tool itself, and conveying that problem is important, because once it's understood by everybody, they quickly see the value in these solutions. Another key takeaway is the importance of understanding our infrastructure requirements. When we started to optimize our data platform, especially Spark, we didn't understand how much infrastructure was actually required to run the given workload. And our default operating model was, if it's slow, just add more infrastructure. Tools like Pepper data have allowed us to see how efficiently that infrastructure is being used, as well as appropriately allocate different resources to it and understand the cost of doing that. Another key takeaway, this kind of optimization is almost impossible to do manually. The automation of this optimization, and not just automation, but autonomous optimization, is critical to hit the price and performance goals that we have. It is much easier for an automated solution like Pepper data to optimize and manage the performance of our clusters, and far more efficient than having people do it manually or staffing teams, whether it's a platform team or a data team. Another thing we learned on our journey is the need for metadata. When we started optimizing for costs, we were very focused on the resources themselves. This cluster costs this much. As we matured, we wanted to get more into How much is a given team costing? How much is their workload costing? That kind of metadata doesn't exist in the clusters or any system. We had to build that. We now have concepts like teams and tenants. We track their use of resources. And we do all of this with our own metadata reporting layer. We had to build a lot of this ourselves as part of the cost management, but we leverage other systems or capabilities, for example, tagging, to make sure that the right resources are associated with the right team. And finally, it's important to carefully consider the build versus buy part of the equation. In the case of solutions like Pepper Data and other related tools for observability, for example, it's far more efficient to buy those tools than it is to build them in-house. In some cases, it's almost impossible to build them in-house. The key is making sure that the tooling, of course, is saving more money than it costs. And we've never had any doubt that with Pepper Data, we're getting the value there. Right. And that concludes the presentation. I want to thank everybody for joining today.